Assalamualaikum to Dr. Sufiza. So for this lab 5, we are going to do clustering analyticals model based on the Candy dataset. So I've already saved this file as lab 5 Candy clustering under the BA lab session folder. So the first operator that I'm going to use is the read CSV operator, since the file that we want to import is the CSV file. It's a CSV file, so since there is no problem, I'm not going to change anything. Finish, and then we are going to run. So the data, as you can see, has been imported in RapidMiner. The next operator I'm going to use is the store operator, so it is easier for me to retrieve whenever I needed it. So I'm going to name it as lab 5 Candy dataset. Okay, and I'm going to run again. So there is no problem, it's just the same dataset just now. So in this analytical model, we want to group, or we want to cluster this candy brand, which is represented by the competitor's name, into a group. So first we have the chocolate attribute, whether the candy represent chocolate or not, and then we have the fruity, is it a fruit flavor candy or not, and then we have caramel, is there any caramel in the candy, and then peanutty almondy, whether the candy contains peanut butter or almond, and then we have nugget, does a candy contain nugget, and then we have crisp rice wafer, whether the candy is crisp rice wafer or cookie component candy, height attribute, whether the candy is a height candy, bar attribute, whether the candy is a candy bar, pluribus, is it one of many candies in a bag or a box, and then we have the sugar percent, the percentile of the candy, the percentile of sugars in the candy, and then we have the price per percent, unit price percentile compared to the rest of the set, and lastly we have the win percent, the overall percentage according to 269,000 matchups. So based on all of these attribute, this analytic model, we find similarity and cluster it into groups or cluster. So I'm going to use the operator set role, and the competitor's name is going to be, the target role is going to be ID, since we don't want to use it when we use this attribute when we do analytical models. So I'm going to run it. So as you can see, the color has turned blue, and if you look here, there is one special attribute, which is this one, ID. I'm not going to use the nominal or nominal to numerical operator or whatever operator, since all of this data has been all of this data is in numerical.
Okay, next, after Ain has cleaned the data, now we will proceed to do the clustering. So for the clustering, we're going to use k-means operator. So we will drag it into the process panel. So for the clustering operator, at the parameter, we will going to tick the add as label, and k is how many cluster that you want to have. So we will use as 2, and then the maximum runs is how many time repetition to do until we stop. So we're going to use it as 10. We set it as 10. So cluster, also we connect it here. Okay, so now we're going to run the process. So after we run the process, we can see here that cluster 1 it is divided by 2, which is cluster 0 and cluster 1. Okay, so this is the competitor name for cluster 0, and for cluster 1, this is all the data. Okay, so as for the cluster model, let's look at it. So here it states that for cluster 0 there are 48 items, and for cluster 1 there are 37 items. So we can also view by the folder. So as you can see here, the cluster 0, this is all the competitor names for cluster 0, and as for the cluster 1, these are all the competitor names. Okay, so let's look at the graph. It obviously shows that 0 is larger than 1, as 0 has 48 items and 1 have only 37 items. Let's look at the centroid table. So here at the centroid table, in cluster 0, the chocolate average is 0.208, and cluster 1 have 0.730 as for the average, and same goes to the other. Okay, so now let's look at the design. We also can change the K to 3. Okay, let's change it to 3 and run the process. Okay, so as we change it to 3, the label we have cluster 0, cluster 1 and cluster 2. So we have 3 cluster here, and we look at the cluster model. For the cluster 0 there are 33 items, cluster 1 there are 20 items, and cluster 2 there are 32 items. Okay, so as you can see here at the root set, obviously cluster 0 have 33, cluster 1 has the smallest, which is 20 items, and cluster 2 have 32 items. Okay, so this is the centroid table. Okay, next, after we have do the clustering, okay, now we are going to use cluster distance performance. Cluster distance performance is to know either the cluster is good or not. So we need to include the cluster distance performance in order to check. Okay, so we're going to use cluster distance performance. So we unconnect everything first. So here at the clustering, we're going to connect the port. For the clustering output port, we connect to the second one. And for the second one at the clustering, we connect it to the first input port of performance. Okay, so we connect this one to the port. Okay, so after we have connected, for the main criterion of the parameter for performance, we're going to use Davis-Baldwin. Okay, so when we choose Davis-Baldwin, we can run the process. Okay, so let's look at the performance vector. So here it shows that the Davis-Baldwin performance vector is, we got negative 0.566. This is when we use K cluster as 3. Let's see if we change it to 2 and we run it again. So we can see the performance vector is negative 0.560. So it shows that when we use 3 cluster, it is better, because for the Davis-Baldwin, when the lower the value, it shows that the better our clustering is. Okay, so I think that's all for clustering model. So thank you.